Hey guys, and welcome to your first online web lesson. What I want to do today, since the first video was just do kind of a short mini lesson that has to do with what we saw today in class. So let's get to it. As you can guess, it's about triangles. And what we were talking about today in class is starting to look at the special relationships that exist between angles in a triangle. And we looked at this angle that we call an exterior angle. And if you remember, we proved in class that angle 4 is actually equal in measure to the sum of angle 1 and angle 2. We did that with a geometric proof that you guys figured out on your own. And just add a few things, just minor things, so that you can complete the assignment tomorrow in class. Let's talk a little bit about congruent angles. So we figured out, or we talked about in class, that a triangle, the sum of the angles in a triangle is always going to be 180 degrees. Let me just zoom that in a bit. And that's not something that a mathematician figured out or that I decided, but that's actually something that's part of the very structure of triangles. There's no way of constructing a triangle where you wouldn't have all the angles summing 180 degrees. So just a couple things. If I were to have, for example, sorry about my bad triangles. If I had two triangles and I knew, for example, that this angle was congruent to this angle, well, is there anything I can say about the other angles based on this? Not really. There's not enough information just yet. But what if I knew this? If I knew that these angles here were congruent and these lower angles here were congruent, what could I say about the third angle? Well, if you already guessed it, you're probably right. These angles here would also have to be congruent. And it doesn't really matter what the measurement of these are. We know that whatever's left over here is going to have to be equal to whatever's left over here, because I already know that these are congruent and these are congruent. So by a process of logical deduction, I know that this angle here will also have to be congruent. To add another thing onto this, well, let's imagine that I have a right triangle. And as you guys know, right triangle is any triangle that has a 90-degree angle in it. And you might ask, well, how many 90-degree angles? Well, as you guys mentioned in class and realize, it's not actually possible for a triangle to have more than one 90-degree angle. Right? If I tried to draw a triangle with more than one 90-degree angle, well, here's my first 90-degree angle. And the second one, well, if I draw it here, it would look like this. That's not going to work. And if I draw it here, it would look like this. So there's no way to close the triangle, right? So I'm only going to have one, at most one 90-degree angle in a triangle. Right? So if I know that this angle here is 90, and I know that the sum of all the angles has to be 180, what could I say about these two angles here, this angle and this angle? Well, I can't know their exact measurement based on what I know here, but I can say something about what's left over, right? If I have 90 degrees here, that means the total sum of the other angles in the triangle are going to have to also equal 90 in order to get this magical triangle number, which is 180 degrees. So if the other two angles have to equal 90 together, then what could I say about them? Do you guys remember the term? They are complementary. Now, is that true about any triangle, no matter what? or any right triangle? Yeah, that's true about any right triangle. There's no way of getting out of this. If the total sum of all the interior angles is going to be 180, then there's no way that these two could not be complementary, right? Because if they weren't, they would either be less than, the sum would either be less than 180 or more than 180. And like we saw before, there's no way of constructing a triangle without this magical number. Okay? So let me just take a look here, see if I'm including everything. And based on that, something we also saw in class, and this will be the last thing we talk about, is that, as you know, we can have triangles that are what we call obtuse triangles. An obtuse triangle is any triangle that has an obtuse angle in it, an angle that's greater than 90. And just looking at this, we can see that this angle here is acute, it's less than 90. This is acute, and this is obtuse. Now the question is, could we have a triangle with more than one obtuse angle? Is that possible? Well, think about it for a second. If you remember, like we said, a triangle has to, the interior angles have to sum 180 degrees. And an obtuse angle is any angle that is greater than 90 degrees. Oh, excuse me. Go this way. Greater than 90 degrees. Well, let's make it really small, and let's say that it's, small difference, 91 degrees. Yeah. Well, could I possibly have two angles that are 91 degrees in a triangle? Well, if you look at it, the two angles here are already summing, if I add them together, they're already summing 182 degrees, right? So what happens to my third angle? I don't have any room left for a third angle. And so it's actually not possible to construct a triangle with two obtuse angles. And in fact, even if I try to draw it, here's my first obtuse angle. Well, where's my second obtuse angle going to go? If I try to draw it here, well, can't close the triangle. If I try to draw it here, also can't close it, right? So there's no way of doing that. So combining what we saw today in class about the exterior angle theorem and a few things about what we saw about triangles that have two congruent angles having to have also a third congruent angle, and also triangles having a maximum of one obtuse angle, as well as this special fact about right triangles, that the two angles that are not the right angle must be complementary to one another. You're going to combine this to just do a really short assignment. What I'm going to ask you to do is I think my page numbers are the same. You're going to go to lesson here 4.2, and I want you to do the check for understanding questions. Okay, that's numbers 1 through 10. Okay. Lesson 4.2. Well, let's make it nice and short. Let's do numbers 1 through 10 evens. Okay, so that's only 5 problems. And bring those into class. I'll give you some points for it, and then we're going to work on it a little more. Okay? Okay, so thanks for watching, and I hope it worked out. Let me know if you had any technical problems at all. You can, if you want, you can leave a little comment on the video below. All right, see you guys tomorrow. Bye-bye.